Large language models exhibit a number of surprising abilities. In particular, they seem to know some facts about the world that might involve things like physical intuition, such as what happens when you push a block across a table. It turns out that we do describe many physical phenomena in language. Furthermore, when we perform instruction tuning or RLHF in language models, their utterances do start to more closely map the world as we experience it. Raphaël Millière and Dimitri Mollo think that human feedback complementing unsupervised learning endows modern large language models with a notion of referential grounding that allows their vector representations of words to hook onto the world and acquire intrinsic meaning that doesn't depend on humans interpreting a system's inputs and outputs. I wanted to better understand how Professor Millière thinks about notions of grounding, so I had him on to speak about his recent paper, The Vector Grounding Problem. We also got into his PhD work on consciousness and self-consciousness, and how these ideas might map on to how we think about AI systems. This is the Gradient Podcast, and I am your host, Daniel Bashir. If you enjoy these episodes, you can follow us wherever you're listening to this podcast episode. You can also follow us on Substack to get regular notifications whenever we release a new article, newsletter, or podcast episode. You can also find our online magazine at thegradient.pub, where we regularly publish essays by the sorts of people I interview on the podcast. And finally, if you enjoy the episode, it would mean a great deal to us all if you'd consider leaving us a review on whatever podcast player you're using to listen to this episode. It helps more listeners like you find what we're doing, and helps us bring in more interesting guests for you to listen to. But now, without further ado, Raphaël Millière. Professor Millière, I think that for me, the combination of ideas, the work that you're doing is probably some of the most interesting that I've encountered recently. And so I'd love to hear a little bit about your background and how you started thinking about AI in the first place.
Sure. So I have a bit of an unusual trajectory, I suppose, for someone working on AI, because I have a background as an academic philosopher. So I have a PhD in philosophy, but very early on, even before my PhD and during my PhD, I've started working a lot at the crossroads between different disciplines, including scientific disciplines. So I have been working with cognitive scientists and neuroscientists during my PhD, and increasingly working on some issues that had some overlap with computer science. And then during when I got hired by Columbia University, I focused more specifically on that kind of collaboration. But my initial interest in AI, I would say that I've had a very long-standing interest in computer science and artificial intelligence, even before I started studying philosophy. I, like many people, you know, when I was young, I dabbled in programming, very simple things in my case, and then I kept following with great interest progress in AI research from a distance, especially since 2012 and the kind of triumph of machine learning, first in computer vision and then in other domains. And when I started my PhD at Oxford, I had this side project where I had this large corpus. I kind of discovered the existence of this large corpus of reports that were of interest to me for my philosophical research, because these were reports of states in which self-representation is disrupted by the intake of psychoactive compounds. So I had this, I scraped this database that has about 30,000 reports, and I was thinking it's a shame that this database exists and it's way too big to be analyzed qualitatively by researchers, but it's a shame that no one is doing anything scientific with this. And so I thought, well, perhaps the progress of NLP, of natural language processing, could help here. I had been following this again from a distance, but I thought maybe that's an opportunity to try to use these algorithms and see what I could do. So this was in around 2015. It was before the Transformer paper. It was before large language models. But basically, I took that opportunity to delve into this and actually train myself to use state-of-the-art models at the time, train my own model on this corpus. So I trained a doc2vec model, so a bit like a word2vec automating model with vectors for documents as well. I also experimented with some topic modeling techniques like LDA and a few other techniques, and I landed on doc2vec. And so I had this project where I modeled the effects described in these different reports automatically with this custom model that I trained. And that really got me hooked because, first of all, I found the process really interesting and enjoyable, even from a technical perspective, and actually getting to know how to fiddle with hyperparameters, train models myself, and so on was very interesting. But beyond that, and most importantly, I thought there are some really interesting theoretical questions related to this kind of model that have been underexplored in philosophy. There is some old work in philosophy that we all know about, around the Chinese room experiment and things like that, related to previous symbolic models, including NLP models. But there was really a dearth of in-depth philosophical work that, taking into account recent developments in NLP, specifically with machine learning models like doc2vec, word2vec, and others. So I thought there are some really interesting questions here. For example, these models represent words as vectors in a high-dimensional vector space. To what extent can we say that this kind of representation captures something about the meaning of words? So I started thinking about this, and from that moment already, so back in 2015, 2016, I thought at some point I would like to work on this, not just as a tool for this side project where I'm just using these models in an instrumental fashion, but really focus on the philosophical questions that these models raise. And I got this golden opportunity when I finished my PhD and GPT-3 was unveiled by OpenAI. And I thought, okay, this is something really big happening here. Like this is a key opportunity to really shift my focus pretty much full time to working on these issues. And so this is what I did. I first wrote this public essay in the magazine Nautilus on GPT-3. The summary came out, and then started working on more academic papers related to various philosophical questions raised by large language models and other models. So essentially, that's how I came to work on that.
I think we'll get to this in a lot more detail once we come to the vector grounding problem. But one thing I have observed in looking at the ways that you and other researchers are approaching some of the philosophical questions surrounding AI today is that in a lot of ways, I think these philosophical questions kind of morph into not just questions about the AI systems themselves, but about our capacities as humans. And I think that there's this kind of two-way reflection, right? Given maybe humans have some relation to the world itself or state of the world, and we have a theory about that, what might that say about language models? Or given that we believe language models have particular capacities, what inferences do we then make about humans? And I feel like that kind of draws into a number of things, but especially when thinking about we are trying to create these systems that maybe we would like to have vaguely human capacities, however we define that, in describing things about their relationship to the world and thinking about meaning, it does feel a little bit hard to escape, especially because humans are involved in creating training data and providing feedback for these models, whether humans have the kinds of relationships to the world we think they do. And I think that can kind of drive one down a whole rabbit hole of metaphysics or other epistemological questions. And so, at a high level, before we get into detail on this later, I'm curious to what extent these concerns factor in your work. Are you maybe a little bit more of a pragmatist where you have maybe the commitment that our our mind's description of the world, our mind's understanding of the world, basically reflects the way the world really is, which I think is key in a lot of kind of metaphysical theories? Or do you maybe have some sympathies for the folks who come along and are like, maybe this isn't the case?
Right. That's a great question. First of all, I am interested in the relationship between deep learning models and human cognition in both directions. So I do think, of course, that taking insights from the philosophy of mind and cognitive science to look at the capacities and limitations of deep learning models, such as large language models, is important. And I have obviously a lot of admiration and follow very closely a lot of technical work in computer science, but sometimes it can be a little, for lack of a better phrase, philosophically naive, or perhaps naive from the standpoint of cognitive science, where it borrows some concepts like attention, memory, and so on, without necessarily always critically examining how these relates to the way in which these concepts are used in cognitive science and philosophy, or kind of rediscovering old debates like the grounding problem, without always going back to its roots in philosophy and cognitive science, that I think can be helpful to inform current discussions. So I think it's important to look at it in that direction when it comes to ascribing certain competencies, certain capacities, to large language models or other deep learning models. We ought to look at human cognition, and also, I would say, non-human animal cognition, and infant cognition. So look at also comparative psychology and developmental psychology to inform at least our methods and the kind of methodological principles we follow to make this kind of ascription. So that's one thing I'm very interested in. And I would have a lot to say about this, because I think the discussion on this kind of issue, unfortunately, tends to be, at least in the public discourse on social media and in public essays and op-eds, very polarized, where very quickly people gravitate towards the extreme, which is either these models are stochastic parrots that show no sign of intelligence whatsoever, or they are harbingers of superhuman intelligence. And there's a very rich middle ground that I'm personally very interested in exploring. Again, adopting this kind of empiricist attitude, taking capacities on a case-by-case basis and drawing inspiration from cognitive science, comparative psychology, developmental psychology, and philosophy to make this kind of ascription. So that's the first direction. And then, as you rightly pointed out, I do think there are some really interesting questions in the other direction when we look at what current models do, and they do really impressive, remarkable things that we tend to, our tendency to be impressed should be, of course, questioned. We shouldn't be too impressed or too impressionables and give way to anthropomorphism. But we also shouldn't forget that we tend to get used to the kind of remarkable things these models can do. Our initial surprise tends to get normalized over time, but these models can do really impressive things. So given that they can do these things in various domains that were once thought to be things that only humans could do, what does that say about our current theories of human cognition? Could we perhaps take inspiration from what we know about how these models work to perhaps revise certain ideas about what we think human cognition is organized, and how we think various aspects of the human cognitive architecture works. So I'm interested in that second direction as well, and I think a number of other people are too. So now I'm forgetting your perhaps the more substantive part of your question, which is about metaphysics. Could you just remind me what?
Yes, of course. So that was more about, I think that a lot of the questions we deal with when it comes to LLMs and their relationship to the world, humans have to come in as a mediator of some sort, pretty much always, in curating training data and providing feedback as an RLHF or instruction tuning methods. And so when we start to ponder these questions of, well, do LLMs possess some sort of meaning? What is their relationship to the world? I think that also necessitates the question, well, do humans have the kind of relationship to the world we think they do? Does the structure of the world as it exists in our mind necessarily reflect the structure of the world as it really is? And so I'm curious to what extent those questions also kind of come into your thinking in all of this.
Right. Yes. So I tend to try to avoid getting too bogged down into this deep, metaphysical questions, because I don't think we necessarily need to get into that to make headway on substantive questions about how language models might come to acquire meaningful representations like humans do. Um, so, questions about realist versus non-realist views in metaphysics, things like that. Um, I don't think are a necessary stopping point on the path to answering the kind of questions that I'm interested in. The work in philosophy that I draw more inspiration from pertains to the philosophy of language and philosophical theories of representations of representation. Sorry. That said, I mean there are some. There are some claims in the vicinity of what you discussed that come up in my thinking on these issues. For example, when you think about how humans come to acquire meaningful representations of the world, there are questions about whether certain kinds of structures, structured domains in the world, have a certain structure that is reflected in the structure of representations in the human mind. So there are, there's a lot of work in philosophy about how correspondence or morphisms come into play in ascribing representational content, where the structure of certain representations in the human mind seems to and things that can be investigated even in neuroscience, looking at cognitive maps, for example, reflects the structure of the world, for example, the spatial structure of the world. And to the extent that your question would extend to this kind of question about the extent to which some aspects of the structure of representations in the human mind or brain reflects the structure of some domains in the world, that is one aspect, one related question that I think about. But the really deep philosophical question about whether, say, we experience the world as it really is, or something along these lines, I think is perhaps a little too general and abstract to directly inform the kind of the kind of question I'm interested in when it comes to language models. I hope that makes sense.
That makes a lot of sense to me. I think that when it comes to what is the project of developing these sorts of systems, you can, or somebody could, drag themselves down all sorts of rabbit holes, but there's something that has to be a little bit pragmatic, I suppose, when we are trying to develop these systems to have the capacities we might like them to eventually to act in the world in certain ways. Well, we humans are capable of acting in the world, whatever you think about the relationship between our mind and, things in themselves, or whatever pet theory you'd like to pick up. And so I suppose, just for the sake of allowing ourselves to get ourselves off the ground, pun intended with that, we do have to assume some kind of regulative capacities, I suppose, and that whatever the status is of whether we really understand the world down to the very basics, the full structure of everything, we are capable of acting in it. And so that's, I guess, the best signal, the best ground truth we could hope for.
Yes, I I agree with that. I mean, it's again there are many centuries of discussions in metaphysics about these issues. There are some very fine-grained discussions that exist in contemporary metaphysics about some of these issues, but I'm happy to put that to the side a little bit and focus on more specific questions pertaining to, say, the acquisition of representations and description of representational contents in systems, both biological and artificial systems.
So let's start working our way towards some of these questions in more detail. But where I'd love to start is during your PhD, you did a lot of very interesting work on self consciousness. And a particular sort that I think has maybe a lot of interest, possibly for our audience too, because we've had a few discussions here and over the past couple of years of what does consciousness, what does sentience mean when it comes to LLMs? Are there gradations of that? What does consciousness necessarily involve? You had some work that looked at, does consciousness constitutively involve self consciousness and awareness of self? And I guess for me, that kind of reminds me of Avicenna's like flying man thought experiment. I know kind of starts to dive into some of these questions. And so I find that a sort of interesting way to come at the same question. But I guess I'd love to hear you introduce some of the work you did on this relationship between consciousness and self consciousness and how that might start to bear on some of these questions that we're thinking about.
Yeah, so in my doctoral work and in related philosophical and empirical papers, I've investigated the relationship between consciousness and self-consciousness, as you just said, and I've argued on the basis of both theoretical and empirical considerations that consciousness does not constitutively involve self-consciousness, meaning that one can be conscious, have conscious experiences, without being thereby conscious of oneself as such. And so being conscious in itself is not sufficient necessarily for being conscious of oneself as such, even though in the ordinary wakeful state, arguably, we do have this kind of pervasive awareness of ourselves that comes through, for example, bodily experiences and spatial experiences. So part of that, there are different strands in that research. So one of them is I defended this pluralist account of self-consciousness, according to which there are several ways in which we can and we do represent ourselves as such. And these ought not to be conflated, as they often are in the literature, when people talk about the sense of self or self-consciousness as a monolithical notion. I think we can actually have a more kind of divide and conquer strategy where we distinguish between different kinds of self-consciousness or different ways of being conscious of oneself as such. So, for example, as I suggested earlier, when we have bodily sensations, many people think this comes with a kind of phenomenology of bodily ownership, meaning that we have a sense of the body part in which we experience the sensation being our own. Most people, philosophers in this literature, kind of describe this as an affective experience. So we have this affective experience of our bodies as our own that seems to pervade our bodily experiences. So perhaps right now, as you're listening to this podcast, you're sitting in a chair or doing something and you have bodily sensations, and these don't feel like they're free floating, as it were, but they feel located in your body. And there's something about these sensations that is distinctively different from perhaps other kinds of experiences you have about the world, because these really seem to be about you in some substantive sense. So if you think that there is such a sense of bodily ownership, that's one form of self-consciousness, consciousness of your body parts as your own, that seems fairly pervasive in ordinary experience. Then there is what I call spatial self-consciousness. So if you think about the spatial content of perceptual experiences, particularly visual experiences, as I'm seeing the world right now, I'm looking at my screen. I see my screen as being in front of my perspective on the world, so in front of me in some sense. So my visual experience, as all of our visual experiences, is structured by an egocentric frame of reference that has a point of origin with respect to which the location of various landmarks in the environment are represented in an egocentric way with reference to that point of origin. And so I've argued that actually underlies a form of a very basic form of self-representation, which is simply perceiving the desk or the screen as being in front of where I am, for example. And so that spatial self-consciousness also something that you might expect to be fairly pervasive in ordinary experience. And then there are more sophisticated cognitive forms of self-consciousness, like thinking of oneself as such. So if I ponder the kind of traits that I have, perhaps my height, my name, my career, whatever, this seems to make use of a self-concept that is deployed in thinking about oneself as such. This self-concept itself is multifaceted. Some of the properties that I ascribe to myself are physical properties, like my height. Others are non-physical properties, like perhaps being a philosopher or things like that. But importantly, that kind of more cognitive form of self-consciousness doesn't seem to be as pervasive in ordinary experience. Unless you're an extreme narcissist, you're not constantly thinking of yourself as such. And also, it seems to be the kind of more sophisticated capacity that we might not ascribe to non-human animals. Whereas things like spatial and bodily self-consciousness, perhaps we could meaningfully and usefully ascribe to many non-human animals, because being aware of your location in space and being aware of your body as distinct from the external world are things that seem to be very useful for the survival of an organism, just to know where you are, know what part of your environment is you and what part of your environment is the external world. These are very basic fundamental things. So I've been interested in tracing back the origins of self-representation by looking more specifically at these very fundamental basic forms of self-representation, like spatial and bodily self-representation, which presumably might emerge fairly early on, both from an evolutionary perspective in our evolutionary ancestors, and being things that are shared with our cousins in other species, but also from a developmental perspective. You think of young children, babies, they will do things like grab their own feet to kind of sample evidence about whether this is part of me or this is part of the external world, and so on. And I did this because a lot of people in philosophy approach questions about self-consciousness from the other end by looking at more sophisticated forms of self-representation first that might be uniquely human, like using the first-person pronoun in language and thinking about yourself as such, this kind of thing. And I was interested in reversing the order of inquiry and looking at the more basic forms of self-representation first. So, as I said, the basic forms like bodily, spatial self-consciousness, they seem fairly pervasive. But I've also argued that they are not necessarily ubiquitous. And you can find evidence for states of consciousness in which these are also missing. And this evidence has some implications for the whole question that I mentioned early on about whether one can be conscious without being self-conscious at all in any way at the same time. And so there are various data points here from psychopathologies and experimental conditions, but one of the sources of evidence that I've investigated more closely, because it had been understudied in philosophy and generally in science too, was evidence from drug-induced states, specifically states induced by various psychoactive compounds that seems to have very dramatic effects on self-representation and the capacity to represent oneself as such, which are transient, so these effects are not permanent. But in the intoxicated state, under the influence of these psychoactive compounds, there is a wealth of converging evidence that individuals might undergo experiences in which they lack the capacity to represent themselves, not only cognitively, not only thinking about themselves as such, but also more generally, they undergo states in which they no longer have a sense of self, even from a spatial and bodily perspective. So bodily sensations can disappear altogether. There are states in which people are no longer aware of their bodies at all, or they can be kind of blend in with um, perception of the world, where people still experience bodily sensations, but they no longer feel connected to themselves in any way. They just feel like sensations like any other, on the same, on par with, uh, you know, visual sensations and auditory sensations, and they no longer have this privileged connection to the self. And same thing for spatial self-representation. There are states in which people say that, there is no longer, visual experience is no longer structured by an egocentric frame of reference. There is no longer this privileged standpoint on the world. Everything kind of blends it into this very confusing maelstrom of sensations. That no longer involves having a specific standpoint, which is where I stand with respect to the external world. And of course, it's very hard to wrap one's head around, what that might even feel like when you study this. But I think that's why it's especially important to look at these very altered states of consciousness, because, I like this phrase by the philosopher Daniel Dennett, who says that we ought to be careful when thinking about the mind and philosophy of mind, not to confuse failures of imagination for insights into necessity. So just because we can't imagine what that would be like to be in these very altered states, doesn't mean that whatever it is like to be in these states is impossible, and that we should think that self-consciousness, at least in these basic forms of bodily and spatial self-consciousness, is always there whenever we're conscious. So that's a bit of a long-winded answer, but that's part of the some of the questions I've been interested in. I have also looked at this from more theoretical standpoints, arguing against the more a priori arguments for the constitutive involvement of self-consciousness in consciousness. But I'll stop here.
This is very interesting to me for multiple reasons, but perhaps the most relevant here is this series of questions I kind of gestured at earlier when it comes to the pronouncements. We've seen some of them feeling overconfident about we have these large language model systems that output reasonably human sounding text. What does that say about their sentience? What does that say about their consciousness? Famously, Blake Lemoine kind of left Google after, or was kicked out of Google after saying that their Lambda chatbot system was sentient. We had, I think, Ilya Sutskever kind of, prod at everybody saying it might be that today's neural networks are slightly conscious. And I found that some folks were able to bring in some more nuance to that debate. So Thomas Dieterich, I think, wrote a thread in response to the whole sentience thing, where he described like multiple different levels at which sentience could occur, which was a very important and clarifying dimension to that. And so what really interests me about your work on consciousness and its relationship to self-consciousness here is I do think that ordinarily there is a lot of this failure of imagination to think about a kind of consciousness that might not necessarily involve that awareness of self. And so when we start thinking about language models or potential future systems, and we want to assess, okay, well, might there be something it is to be like that system? It does seem plausible that whatever possible phenomenological experience that system could have, if it does have any at all, is probably going to be wildly different from anything I could imagine in the classic what is it like to be a bat sense. And so I'm curious if to what extent you kind of think about this intersection between consciousness where self-consciousness is not necessarily a constitutive component, and then how that might bear on some of these questions.
Yeah, so on the consciousness question, my stance on this is perhaps a little disappointing, but I think that the question whether current language models have conscious experiences at all of any kind, that I would include claims like Sutskever's claim that perhaps language models are slightly conscious, whatever that means. And I think there are reasons to doubt that consciousness comes in degrees, in the sense that people often assume that to be the case. There's some relevant literature in philosophy there, but leaving aside the whole degrees question, do language models have any conscious experience at all? I think that question is sadly underdetermined by available empirical evidence in light of current scientific theories of consciousness, which are, to put it in a slightly pessimistic way, are still in their infancy, still very much underdeveloped, and as long as they are underdeveloped or incomplete, the hopes of making a lot of substantial progress on assessing the existence of conscious experience in the systems is pretty grim. I think that's the first part of my answer. I have kind of two-tiered stance on this. The second tier would be, given that we cannot establish with any certainty whether these systems have a conscious experience at all, we can still make a very informed guess about what is plausible or implausible, and to a degree. And there I side with people who say it is wildly implausible that current systems have conscious experience at all. And the reason for that is that if you look at current candidate scientific theories of consciousness, there are a few that are taken seriously by researchers in cognitive science and in philosophy. They do generally agree on some features that, at least in biological organisms like humans and non-human animals that are plausibly deemed conscious, or have plausibly, that can be plausibly described the capacity for conscious experience. There are some features that seem to be associated with consciousness, and many of these features seem to be lacking in current large language models, for example, if you look at the architecture and the way they work. So an example would be recurrent processing. The brains of mammals, especially the human brain and other mammalian brains, have a lot of recurrent connections, a lot of not just feed-forward, but feedback connections. And recurrent processing seems to play a fairly important role in the shift from non-conscious to conscious representation, the ability to have conscious experiences or to perceive things consciously as opposed to non-consciously. And if that's the case, well, that's interesting, because current language models are just feed-forward architectures. They don't have these kind of recurrent connections. Thinking of transformers here. And to that extent, they seem to perhaps be missing one of the key features associated with consciousness in biological organisms. Of course, it is not impossible that consciousness might be realized in a different way in the systems. If you think that consciousness can be realized by different kinds of structures, and that a feature such as this one is not a necessary condition for the occurrence of conscious experience. Nonetheless, I think it's one of several very suggestive data points that kind of strengthen the claim that is very implausible that current language models have anything like conscious experience. The other thing I wanted to mention is that when it comes to the question of how consciousness relates to self-consciousness or self-representation in artificial systems, there is a kind of a double dissociation there, where you can have a system that has the capacity for self-representation without that system being conscious at all, because self-representation can be non-conscious, right? If you take a very liberal perspective, very deflationary perspective, you might even say that a self-driving car that needs to track its own location in space with respect to its environment implements a very basic form of non-conscious self-representation. It's very basic, but nonetheless there is this tracking of one's location in space, and if you if you have a very liberal view of self-representation, you might say, well, that's a very basic form of self-representation, and it doesn't require consciousness. So that's the first association. And in the other direction, you can have a system that has conscious experiences without representing itself in any way, as I've argued in my work with humans. So I'm always careful when discussing these issues, because often people, especially people who don't have a lot of exposure to the philosophical discussions, tend to kind of equate consciousness and self-consciousness, or equate the capacity for self-representation with the capacity for consciousness, or vice versa. And I think that's a leap that we ought not to make because of this double dissociation. So the question whether current systems have anything like a form of self-representation, I think is very interesting. In the case of self-driving cars, this is kind of built in, hand engineered, as it were, by the engineers making the system, because you build in this capacity for distinguishing between the location of landmarks in the environments from the LiDAR data and from the camera data, for example, from the location of the vehicle itself. In language models, you don't have any kind of built-in capacity for self-representation, and so it's interesting to discuss whether there is this kind of emergent capacity for self-representation that would emerge from training. I don't see any strong evidence that this is the case so far. I know people concerned about AI safety are concerned about that and thinking, well, perhaps there will be at some point this kind of emergent capacity for the systems to represent themselves, regardless of whether they're conscious or not, just represent themselves and their own processing and their own, perhaps develop something like metacognition, being able to reflect about their own thinking process. But I don't see any strong evidence that this is the case at this point.
I think I broadly agree with you on all of those prongs. The very important one that many of these questions are underdetermined and are probably going to remain underdetermined because we just don't have the scientific tools to properly assess them. And also on the wildly implausible front, that being said, it is, and I guess an important rung of this is the need to really be a bit more granular in our discussions of this than consciousness or not conscious, or having consciousness or not having consciousness, or when it comes to self-representation, because certainly, and this speaks to, I think, some human biases and the ways that we engage with things, many of these chatbot-like systems certainly present as maybe having some kind of self-concept. At least if you ask it questions about itself, it would answer as though maybe it has some kind of coherent self. And of course, maybe if you question it for long enough, you'll kind of end up in contradictions. And it's like, okay, this is not exactly what I thought. But at least in limited enough interactions, you can really feel that sense that this thing kind of presents as having some internal coherency, which is very odd, I imagine, for many people who haven't thought about these questions as carefully as you have.
Yeah, that's a good point. And I think the fact that language models use the first person pronoun, for example, by default, is probably responsible for a lot of the anthropomorphic attitudes people have towards these models. Because you have here a system that uses the first person pronoun and says, as a language model, I cannot do blah, blah, blah. Or, this behavior is not unique, but somewhat in its consistency is somewhat specific to models that have been fine-tuned with reinforcement learning from human feedback. So just in case the listeners aren't familiar with this technique, reinforcement learning from human feedback, or RLHF, is a method that is used to refine the behavior of large language models after they have been pre-trained on a lot of text data. The pre-training objective is next word prediction, to simplify things a bit. Namely, the model is going to sample sequences of text from a very large corpus, which is a subset of the whole internet. And these sequences of text, generally for current models, span a few thousand words. And for each sequence of text, for each window of text that is sampled, they are tasked with predicting the word that follows. And they start by being really bad at this task, no better than chance, and gradually get better because you can compare the prediction that the model makes to the ground truth, what is the actual word that follows that text sequence, and then calculate a measure of the error, how wrong the model is in its prediction, and propagate this quantity back into the model by adjusting the knobs of the weights in the model to gradually make the model a little bit better at each step at predicting the next word for any given sequence. And you do that over and over again, millions of times, and over time the model gets better, and then it is pre-trained. So then you have this model that is pre-trained that can output plausible sounding text. But now you want to make the behavior of the model a little more reliable and consistent, especially you want it to give answers that, as much as possible, abide by what researchers call the 3 H's, namely honesty, harmlessness, and helpfulness. So you want the answers of the model to be helpful, to be harmless as much as possible, and to be honest, meaning not making things up when you ask factual questions, telling the truth. And to do that, you use this technique, RLHF, where you have the model given certain prompts that are selected to be prompts that could be problematic because it could lead the model to give answers that are not helpful, not harmless, and not honest. So you give these prompts and you ask the model, for example, to generate several outputs for these prompts. And then you ask human raters, crowd workers, to, there are various ways to do this, but one of the most popular ways to rank the outputs from best to worst. Say you ask the model to produce 4 outputs for a given prompt, and you ask the raters to, the human raters to rank these. And then you can train a reward model on this feedback, on this human feedback. And doing that, you can then use this reward model with reinforcement learning to fine-tune the original pre-trained model to systematically correct its behavior such that at the end of the day, when it's been fine-tuned, its outputs will reflect human preferences as to the generation of answers that are helpful, harmless, and honest. The reason why I mentioned this, and I'm sure we'll come back into it later in the discussion, but I mention this now because the tendency for models to use the first-person pronoun in a way that is somewhat systematic and reliable is greatly bolstered by this RLHF fine-tuning. Because when given certain prompts, such as, explain how to hotwire a car, which is a prompt that you don't want the model to answer because it could be harmful, RLHF fine-tuning will lead the model, steer the behavior of the model towards giving a kind of boilerplate answer that is acceptable, such as a language model, I cannot tell you how to hotwire a car because that would be harmful, and I am programmed not to be harmful. And so when you kind of confronted with that output as a user, and you're not familiar with the kind of nuts and bolts of training of LLMs, it's easy to jump to conclusions and say, oh, okay, this is a system that has a kind of self-concept and has certain beliefs about what is harmful or not, and certain desires and preferences, and has all of this rich psychological tapestry that we associate with the use of the first-person pronoun in humans. And that is misleading, I think. That is not to say that I am reluctant to ascribe any kind of psychological capacity to language models. Actually, I again try to avoid this kind of false dichotomy between the stochastic parts view on the one hand, that these models display none of the trappings of intelligence, or on the other hand, the kind of hyped up view pushed by perhaps some people in AI research, some venture capitalists, that these models are harbingers of superhuman intelligence, and basically scaling them up will lead to human-like intelligence. There's a rich middle ground, and that said, I think jumping to conclusion about the use of somewhat consistent use of the first-person pronoun to ascribing the capacity for self-representation in the system is somewhat problematic. So again, here we're kind of bumping into this question of which share of the model's behavior is akin to a kind of mimicry of human behavior that has been reinforced through things like RLHF fine-tuning, and which part is more than mimicry, is actually emulation of human-like psychological traits. The capacity to use the self-concept in this way, the first-person pronoun in this way, I think is more on the mimicry side of things, because if you probe further, you can actually see that there is no consistent set of anything like sets of beliefs about the self in these systems. If you engage them in creative fiction, they will happily take on various different personas that don't display any kind of consistency across prompts and across outputs. So yeah, I think we ought to be careful, and I do see why people are very taken by this use of the first person pronoun, because this is the first time in human history where we've encountered systems other than human beings themselves that are able to speak fluently, and moreover speak fluently using the first person pronoun in a way that seemingly seems to self-ascribe beliefs, desires, preferences, and so on in this somewhat consistent manner. And so that is very compelling. It gives you this very strong illusion that you're talking to a system that is able to represent itself.
Indeed. Another topic that I think calls for the kind of care that we're thinking about here, and that I'd love to spend quite a bit of time on, I think, is some of the questions you've begun investigating recently regarding grounding and compositionality. And I feel there are many kinds of questions and concepts to begin with here as we kind of work our way towards the vector grounding problem preprint that you recently published with Dimitri Molo. And so maybe just to get us started with a few concepts we can kind of introduce to get a grip on things a little bit better. You've described the way that large language models are trained, and they form vector representations of tokens, of words. And so in maybe the stochastic parrots paradigm, or not necessarily that paradigm, but in related thoughts, there is, when we're thinking about do these systems, do those words, do those vector representations mean anything to them, one might think, well, these vectors, a word is defined by the company it keeps. So my representation of a word really is only a definition that's based off of a bunch of other words that have no inherent meaning of their own. And so I think that kind of speaks to some different types of semantic competence that you've distinguished between. But I guess I'd love for you to introduce sort of how you begin to think about some of these questions of what grounding is in LLMs, and then some of the concepts that kind of come into play when you begin thinking about that question.
Yes, sure. So there is a long tradition in philosophy and cognitive science of asking, even before artificial intelligence came around, how is it that we humans, at least, seem to have words or use words using lexical concepts, representations of linguistic representations corresponding to these words, such that we can refer to things out there in the world that these words are associated with. So when I use the word dog, I'm referring to dogs out there in the world. How is that connection secured? And when people started experimenting with computer systems that could make use of linguistic items of language early on in the development of artificial intelligence, specifically, for example, with the early symbolic systems in the 60s, like CHRDLU, ELIZA, and others, that could manipulate language and could seemingly make reference to objects in a virtual world, for example, in the case of CHRDLU, which is a system developed by Terry Winograd. This question emerges specifically with respect to the systems. In the case of these systems, can we say that their use of language, their use of words, is connected in the right way to whatever these words refer to? We humans have seemingly the capacity to secure that kind of connection. But these systems don't acquire language in the way humans do. They don't even kind of evolve in the real world in the way humans do. They are trapped in this text-only world, or at best in this virtual world of virtual objects like CHRDLU. And so there is a question as to whether the meaning of the words they use is only determined extrinsically by human interpreters. For example, the human programmers who are defining the semantics of the system, in the case of these old school symbolic systems, by saying the words triangle for CHRDLU refers to virtual triangles in this blocks world. So CHRDLU is a system created by Terry Winograd, as I mentioned, where you have a component of the system that can parse language, where you can give it natural language instructions in English, for example. And in response to these instructions, it can manipulate geometric shapes or blocks in a virtual world called the blocks world. So you can say, pick up the red pyramid and put it on top of the blue rectangle or something like that, and it can do that. And so its use of words like pyramid, the way in which the meaning of these words is secured, and the way in which the reference of these words to the virtual pyramids, the blocks world, is secured, is extrinsic. It is enabled by this handcrafted semantic interpretation that is given by the human programmers that say the word pyramid is connected to the object pyramid in the blocks world. So the question that emerges, that has come to be known as the grounding problem, is how can we have an artificial system where that uses natural language, that uses words like English words, where the reference of the word it uses is secured not through this kind of extrinsic interpretation given by the programmers, but intrinsically, such that the representations of words that the system makes use of are intrinsically meaningful. They intrinsically refer to whatever the words refer to out there in the world. So how do we secure this connection between words and the world? Or in other words, how do we ground the meaning of words that the system uses into the reference of these words? And so that's the classical grounding problem. It's an old problem. There are various versions of it that kind of came up in philosophy and linguistics and cognitive science over the years. There's an early example from the work of Barbara Party, for example. But there is one canonical paper from 1990 by Stephen Harnett called The Symbol Grounding Problem that really is one of the canonical locus classicus of this discussion, where Stephen Harnett framed this problem with respect to these classical symbolic systems. What's interesting is that in recent years there is a resurgence of this kind of discussion because of the impressive development of large language models that seem to be able to use words fluently. And so people in computer science and computational linguistics have been reviving this old grounding problem, but generally not making reference to these older discussions. And so one of the things we do in this preprint that I wrote with Dimitri Molo is that connecting this discussion back to its roots in philosophy and cognitive science, because sometimes people lose sight of how this debate initially emerged. And I think we can learn from these past discussions. But people have started to talk about the grounding problem with respect to language models. And although the details are a bit different, because language models do not make use of discrete symbols like old school AI systems, but instead they make use of vector representations. So they represent words as vectors in a continuous vector space. If you abstract away from this difference, the problem remains basically the same. How can language models acquire representations of the meaning of words that is a representation of words that is intrinsically meaningful, that is connected to the reference of the world, and not just extrinsically meaningful in the sense that it would just have meaning for a human interpreter. So we wrote this preprint with Dimitri to investigate that question, and perhaps I can stop here and I can tell you later about the positive view that we're putting forward, but that's the setup.
Yes. So you mentioned the original 1990 symbol grounding paper by Harnad, and it strikes me in his conceptualization, and you pointed at this as well, how related it is to this particular sort of grounding, right? The sensory grounding that you were speaking of, because that is one way for me to know the world when I think of the concept or my representation of an apple that is also tied to the experience I can have of like grasping an apple, of eating an apple. And for Harnad, I guess a lot of this purpose kind of ties very closely with his conception of what a Turing test should be. My understanding is he kind of often articulates this idea of like a lifelong robotic Turing test, where you have this system that is kind of in the world, and we're not playing this mini game of, convince three judges over text that you're a human for about 10 minutes, but rather be convincing over the course of an entire lifetime as this kind of ideal point of the type of system that we're interested in here, and whether that system achieves grounding. So maybe taking that as a starting point, I'd love for you to start working your way towards, you introduce a few different types of grounding in this paper and kind of work out which one is most relevant for large language models. And we are here in, of course, a paradigm that is naturally a little bit more restricted than what I think Harnad envisioned, because we're not dealing with robots here. We are dealing with these text-based systems. But yeah, I guess I'd love for you to introduce, kind of coming off of where he started, how you're thinking about this question.
Yeah, so in that paper with Dimitri, we kind of noticed that the discussion on grounding in recent years, at least, but even going back to older discussions, seems to conflate different notions under this heading of grounding. And so we think it might be helpful for future discussions to neatly disentangle these different notions. So we find 5 different notions of grounding that are occasionally conflated because people just refer to this as grounding without making this distinction, and that there is a risk of verbal dispute there because people might be talking past each other. And so, I think this can be the benefit of a philosophical investigation, and the kind of contribution philosophers make to this kind of discussion is to try to make some conceptual distinctions, even though that sometimes give us philosophers a bad rep because people would say well, we're splitting hairs and so on. But we do think this is helpful. So here we distinguish between 5 different notions of grounding. The first one is the most canonical, important one, and we end up saying that this is the key notion that really the grounding problem hinges on. This is what we call referential grounding, and this is the questions of how representations are of lexical representations of words or linguistic items are connected to things out there in the world. How are they grounded in this external reference that enables them to represent worldly entities and properties? That's referential grounding. When I use the word dog, how does that refer to dogs out there in the world? And there's a second notion that we call sensory motor grounding, and it's about the connection between internal representations themselves, the connection between representations between themselves and other representations in the world. So, for example, the connection between lexical concepts, like my concept of the word dog, and sensory motor representations within a cognitive system. So my concept of the word dog is connected in an appropriate way to, say, my visual concept of a dog, by my knowledge about what a dog looks like. And a lot of people, when they talk about the grounding problem, seems to be talking about something like that. So, for example, when people talk about multimodal, vision language models, like DALL-E 2, for example, or Stable Diffusion, some people say, well, these models overcome the grounding problem because they are trained not just on text, but on text and images, also GPT-4 would be in that category. At least one version of GPT-4 can take in images as input. So they would say these systems overcome the grounding problem because they text not just text, but text and images as input, and they can connect visual and linguistic representations up together. But one of the points we make is that we shouldn't conflate sensory motor grounding with referential grounding. So connecting linguistic and visual representations, for example, doesn't really get you out of what Harnett called the merry-go-round of representations, or the carousel of representations, where you are going from representation to representation, but you're never escaping that connection, internal connection between representations, to actually secure a connection to the external world, right? So that's sensory motor grounding. And then very quickly, these are a little less important for our argument, but there are other notions of grounding that are discussed and conflated. So there is what we call relational grounding, which focuses on relationships between lexical concepts themselves, or intralinguistic relationships, where a word's meaning is partly determined by its relations to other words in the language. So, for example, our lexical concept of dog is connected to a lexical concept of a pet, a lexical concept of furry, and that's an important connection that seems to be relevant to at least part of the meaning we ascribe to words. But arguably, it's not the totality. The totality of word meaning is not entirely secured by this kind of intralinguistic connections. Then there is what we call communicative grounding, which is about establishing common ground between speakers in conversations. So people talk about grounding because there's this idea of common ground. So this is to ensure mutual understanding and to coordinate identical reference when we use words. So when I use the word dog and we use word dog, we want to make sure that we're referencing the same thing. And so in conversation, there is this kind of dynamical process of checking that the other person understands the words we use in the way we mean them. And some people call this grounding. We call this communicative grounding, to distinguish it from the other notion. And finally, there is this more secondary notion that is sometimes used in computer science, which is about the relationship between a linguistic expression and information that is stored in the knowledge base. So that's the case in, for example, old school symbolic expert systems. You might have a use of the word dog that is connected to a database of dog facts about dogs. But, people also talk about this kind of grounding in the context of large language models, because there are these papers that compare large language models to knowledge bases where certain words are connected to bodies of information that have been memorized by the system, such as facts in a certain domain. So we call this epistemic grounding. So we have these 5 notions: referential grounding, the most important one, sensory motor grounding, relational grounding, communicative grounding, and epistemic grounding. And the point we're making is that first of all, we need to be clear about which one of these notions we're talking about. And secondly, what we call the vector grounding problem, so the grounding problem applied to language models that use vector-based representations. The grounding problem is concerned with the first notion, the notion of referential grounding. How do we connect linguistic representations of linguistic items to their reference in the world? So that's how we set up that discussion.
Speaking to the broader question you began with in gesturing at referential grounding, the idea of lexical representations and their connection to things in the world, I'd love to dig a little bit further into your thoughts on this question specifically and how that relates to the task of language modeling and what these models do. I think that where a lot of this begins, we have the famous distributional hypothesis that we kind of gestured at earlier, that words are defined by the company they keep. I've heard people who are very bullish on language models quote stuff in later Wittgenstein as kind of a justification for some of their views on why these systems are so powerful. And I guess a closely related concept in Wittgenstein this kind of brings up for me is the whole family resemblance idea. And I should probably flag that this is maybe a little bit more about like concepts than individual words or lexical tokens, but just that even when it comes to concepts, there's this contextuality to them. So something that is chair like in a particular situation is not going to be chair like in another situation. And so there's this aspect of like my grip on the world that in a particular moment I can intuit that something maybe qualifies as a chair in that particular situation. And that feels like something that when I start to think about just gleaming things about the world from just a sequence of text itself feels a little bit harder to compress into it. But I'm a little bit curious how you think about some of these questions as well.
Yeah. So let me start with the distributional hypothesis. Just to make it a little bit more explicit what this is and how this came about and how that relates to current discussions.
Yeah.
So this is an idea that came from structural linguistics in the 1950s through the works of people like Zelig Harris and J.R. Firth, who were linguists in this structuralist tradition. And the structuralist view of language posits that linguistic units, linguistic items, acquire meaning through the relationships with other units in the system. And Zelig Harris, this linguist in the 50s, suggested that specifically that the meaning of a word could be inferred by examining its distributional properties, meaning the context in which the word occurs. So you can look at a corpus of text and look at the context in which the words occur, meaning what are the neighbors, what are the words that are surrounding this word, and this will give you some information about what the word means. And this is somewhat intuitive. Think about the word apple and pear. Apple and pear are two words that would both occur near the same other words very often. They will occur near the word pie, for example, because apples and pears are both two things that can be baked in pies. They will occur near the word fruit, because these are both fruits. They will occur near the word eat, because this can be eaten, and so on and so forth. So as you alluded to, J.R. Firth, a few years after Harris published about this kind of hypothesis, summarized it with this slogan, "You shall know a word by the company it keeps," which is a nice way to think about this idea that the meaning of words is determined by their relationships to other words and by the distributional properties of words in language, how the words distribute in language. And Firth also acknowledged explicitly the influence of Wittgenstein, which is interesting. So specifically the later Wittgenstein, as you alluded to. So the work of Wittgenstein is classically divided into two periods. There is this this book that Wittgenstein wrote in the later part of his life called The Philosophical Investigations, in which he puts forward this conception of meaning as use to highlight the importance of context in understanding linguistic meaning. And so Wittgenstein famously says that the meaning of a word is in its use, and that influenced people like J.R. Firth and these structural linguists. Just as an aside, it's interesting because the work of Wittgenstein is famously difficult to interpret. There are many people who have been influenced by Wittgenstein, but in different ways, and disagree about how to interpret his work, both the early Wittgenstein and the late Wittgenstein. And the late Wittgenstein's legacy, specifically in natural language processing and computational linguistics, is very fascinating because today, when you look at the discourse on language models, you will find people on both extremes of the spectrum appeal to Wittgenstein to draw opposite conclusions. So on the one hand, you would have people like Felix Hill and Steve Piantadosi in their paper on meaning without reference that kind of pushes this distributional semantics line that the meaning of a word is in its context of use. They appeal to Wittgenstein to make that point. And so they appeal to Wittgenstein, to the late Wittgenstein, to say language models can have meaningful representations of words, or they can understand meaning or represent meaning, because they can very powerfully leverage distributional properties of words in a large corpus. That's what they do when they play this next word prediction game. They end up modeling very precisely the distributional statistics of word use. And on the other hand on the other end of the spectrum, you have people like Emily Bender and Alex Kohler. They had this very influential paper called Climbing Towards NLU, Natural Language Understanding, in which they claim that there is this absolute divide between the form of language and the meaning of language. Where the form of language is kind of its syntax and the symbols that are manipulated, like words, and put together in expressions. And they say that language models are very good at learning about the form of language, learning about how the symbols that are words or tokens come together in syntactic constructions. But they know nothing at all about the meaning of language, because there is, in their view, this absolute divide between form and meaning. And they also appeal to Wittgenstein, to the late Wittgenstein, to say, well, if the meaning of a word is at least partly determined by its use, truly making use of words, using language, being a language user, involves communicating with other people and having communicative intentions and representing other people's communicative intentions. So that's not just manipulating tokens and putting them together in well-formed syntactic expressions, but that's about meaning things when you use tokens, having an intent to communicate certain things. And they say that's a key feature of Wittgenstein's view that is missing from language models, because they don't have anything like an intention to communicate anything. They just play this next word prediction game that is purely formal, and they don't have this capacity for communicative intentions. So it's just interesting that Wittgenstein, that its legacy is kind of multiple and heading towards very different directions. But just to come back to the distributional hypothesis, so the way we get from there to language models is that as research on this hypothesis progressed from this early work in structural linguistics in the 50s, researchers began to explore the possibility of representing word meanings as vectors in a multi-dimensional space, which is the key idea behind language models. And there's actually early work in that area that came from psychology and not from linguistics, with the work of people like Charles Osgood, who examined the meaning of words along various dimensions, such as valence or potency, by collecting judgments from human raters. And so that work introduced the idea of representing meaning in a multi-dimensional vector space, relying on explicit participant rating about the connotations of words along different scales. So this was not, at the time, relying on analyzing the distributional properties of a linguistic corpus. But then follow-up work kind of connected these two things. So the distributional hypothesis, the idea that words, or the meaning of words, is secured by the distributional properties of words on the one hand, and on the other hand, the idea that you can represent word meaning as a vector in a high-dimensional vector space. And these two things together gave rise to eventually to the development of word embedding models that we mentioned earlier, like Word2Vec in the 2010s, and then more recently to the large language models we have today. And so because large language models learn to represent words by playing this next word prediction game, where they have an input sequence or context window, and they try to predict which is the word that follows, and then they adjust the vector representation for words accordingly, they end up having these representations of words as vectors in a high-dimensional vector space that very finely captures distributional properties of words, such that words that tend to occur together will have vectors in the system that are close together in the vector space. So that's kind of the basic first order co-occurrence statistics, which words tend to co-occur. But it goes beyond that. You also have, it also captures second order co-occurrence statistics, such as which words tend to co-occur with the same other words. So again, apple and pear, even if they don't co-occur together very often, I mean, it's probably a bad example because there are plenty of sentences that use apples and the word apple and the word pear together. But assuming they don't occur together, they will still co-occur with the same other words, like pie or eat or fruit. So that is also captured. And there are many other kinds of distributional statistical relationships between words that are captured in this way. And that ends up undergirding the capacity of these models to represent fine-grained syntactic relationship between words, but also more semantic relationships about the meaning of words. For example, you can look at, even in older word embedding models, you can look at the vector for queen and the vector for man and the vector for woman, and you can do arithmetics with the vectors. You can say what is queen plus woman, queen plus man minus woman, and the resulting vector will be closest to the vector for king. So you have this ability to capture analogical relationships like this, and many more fine-grained relationships. So this is what led people to think that you are capturing some really important part of word meaning with that kind of approach, building on this distributional hypothesis.
Right. So I guess my kind of question for you, kind of stemming out of all this, is where we tend to land when it comes to your views on the vector grounding problem. So you come to, as you were mentioning earlier, a positive conclusion in this paper that it is possible to overcome this problem and achieve some notion of referential grounding. And you introduce some theories of representational content in service of coming to that conclusion. Could you describe that in a little more detail?
Yeah, so the idea is that this kind of distributional relationship between words, that does not really solve the grounding problem, because the grounding problem as we define it and as it has been classically defined pertains to referential grounding and not to what we call relational grounding. Relational grounding would be about connecting word representations together through things like definitions, paraphrase, summaries, and so on. And we say that the problem of what the grounding problem is about how words connect to the world and the reference in the world. So can and do language models overcome that problem? We say that they do, and we build on philosophical theories of representation to make that point. So we say that, according to the leading philosophical theories of representation, representational content is secured by causal-informational and historical relations between the representation of the system and whatever these representations are about. So one first thing that we point out is that we already alluded to that earlier in the discussion, is that there are some structured domains in the world whose structure is pretty well reflected by structural properties of language that can be learned by language models. So an example would be spatial terms or color terms. Spatial terms such as above, below, right to, left of, right of, in front, behind. These the kind of distributional properties of these terms tends to correlate with the actual spatial structure of entities in the world. And with color terms, the use of terms like blue, red, yellow, and so on, the distributional properties of these words also tends to correlate with the way in which colors are actually organized in a space that is not the physical space, like with spatial terms, but is the color space. So you can represent colors in a three-dimensional space with dimensions corresponding to hue, saturation, and brightness, for example. And that is a structured space where colors can be represented as vectors in 3 dimensions. So there is some empirical work that we discussed in the paper, work by, for example, Eli Pavlik and collaborators, that shows that you can find a structural correspondence or an homomorphism between the vector representations of color terms and spatial terms, for example, and the actual relationships that corresponding relationships in the world between objects or colors in a physical space or in color space. So you have this homomorphism between representations of linguistic items and the structure of the world in certain domains. That's interesting because that already puts a little bit of pressure on this claim that there is this absolute distinction between form and meaning in language, in the sense that the form of language here, referring to these distributional properties of language, is not separated or divorced from the meaning of words, because there are these correspondence relationships with the world and the reference of words in the world. But that's the first step, but we say that that's not sufficient because there is a lot of long literature in philosophy showing that this kind of correspondence relation is not sufficient to secure meaning, because there is well-known problem of indeterminacy, where homomorphisms are kind of cheap to find, and you can find homomorphisms between two domains in a number of different ways, and it's not sufficient to secure specific content of representations. So one of the things that you need also is a kind of historical process that fixes the content of representations. That can be a learning process. So in the case of large language models, they are trained, they are artificial neural networks that learn from data. And so a key part of the story about how they might come to acquire meaningful representations will be determined by considerations about how they learn from data. And the classic objection here is that they learn from a next word prediction learning objective. Namely, playing this next word prediction game, trying to predict the next word in a sequence of text. And that's something that seems to, at best, lead the model to acquire intralinguistic functions, where they can't acquire any meaningful representation about the world, but only represent intralinguistic relationships. It's a function, a learning objective that only applies at the level of relationships between words by playing next word prediction from sequences of words. And what we suggest is that there are various considerations that could lead you to think that language models can acquire more than just intralinguistic functions in this way through their learning process. And the more compelling case, I think, what is more likely to convince the most people, comes from what we talked about earlier, which is RLHF fine-tuning. So modern language models, the ones that GPT-3, ChatGPT or GPT-4 are based on, they are fine-tuned with RLHF, so again, using human feedback. And this human feedback is feedback about outputs that are harmless, helpful, and honest. And the last component, these are all normative criteria. And the last criterion of honesty in particular is not just normative, but epistemically normative, because it's a criterion that's about the accuracy, the factual accuracy of the outputs of the model. And so when these models are getting fine-tuned with RLHF, with reinforcement learning through the reward model that was trained by looking at human preferences, the learning objective is no longer just next word prediction. It is actually getting trained or fine-tuned with this explicit objective, normative objective that embeds human preferences about truthfulness or accuracy. And we think that actually is sufficient to endow the model with a kind of descriptive normativity that secures a world-involving function sensitive to certain accuracy conditions about how the world is. That is the missing ingredient to get intrinsically meaningful representations, not just of relationships between words, but about how words connect to the world. So, for example, part of RLHF fine-tuning might be giving human feedback about the model's outputs about two questions about the capitals of the world. What's the capital of France? Paris. So the human feedback will say that Paris is a better answer than Berlin, for example. And that's feedback about how the world is. And that secures certain accuracy conditions and conditions for misrepresentation that is world involving, not just language involving. So in a nutshell, that's why we think that RLHF provides the missing ingredient in accordance with theories of representations, because it explains how content can be fixed in large language models through not just causal informational relations with this kind of especially through this kind of like morphisms between the representations of the model and structured domains in the world, but also through a historical learning process that involves normative world-involving functions and not just intralinguistic functions.
This question might get us a little bit into the weeds here, but I did want to ask about this particular bit when you're getting into the question of causal informational relations. You say an additional requirement often mentioned is that the causal relational informational relation be exploited, that is used by system due to its information carrying nature, and you reference some other work here. And I guess to me, on reading this section, exploit is doing a fair amount of work. And so when I hear exploit, I think that naturally kind of has to do with exploiting towards something for some purpose. There's like a teleological aspect to that. And so I guess I'm curious to what extent you would get serious about the teleology involved in this. And I guess what I'm wondering there is maybe the aim itself to which we're exploiting causal informational relations also requires some content. And so in thinking about these theories of representational content, we come to some of the same questions about that aim itself.
Right. Yeah. So just to backtrack a little bit, give it a little background here. What we reference in the paper and what you alluded to in the background is a certain kind of theory of representational content known as teleosemantics. So it's part of the broader project of naturalizing representational contents, giving naturalistic account of mental content in philosophy. And teleosemantics is often thought to be a particularly compelling solution to the problem of intentionality or meaning, that is how mental states in human and non-human systems can come to be about things in the world, or can come to represent things in the world. And so it just to finish on that kind of background, the term teleosemantics come from teleology, which refers to kind of the goal-directedness of a system or the purpose of a system. And semantics, of course, refers to meaning or to the representation. So according to teleosemantic theories that have been put forward by people like Ruth Millikan and others in philosophy, the representational content of a mental state is determined by the function that this state has for the organism. And the function here in teleosemantics is understood in a biological or an evolutionary sense, broadly speaking. So the idea is that a mental state represents whatever is its function to represent. And the function of the system is typically understood to be something that has been selected or stabilized in the course of evolution or in the course of a kind of learning process or historical process, because it enhanced, for example, in evolutionary terms, it enhanced the fitness of the organism's ancestors. So that brings us to this idea of causal informational relations. So a causal informational relation exists when a certain type of event or a certain type of state of affairs reliably causes another event or another state of affairs. So for example, if you have a fire, that's an event, typically causes smoke, which is another event. So fire, the occurrence of a fire causes the occurrence of smoke. And we can say that there is a causal informational relation between fire and smoke in this case, right? Because smoke carries information about the presence of a fire, typically. So when it comes to mental representations, teleosemantics suggests that a mental state represents whatever it has been beneficial, at least in evolutionary terms, for that state to carry information about. So it's beneficial for a certain type of mental state to carry information about the presence of, for example, food and in a certain organism. And if that's beneficial, then that mental state represents the presence of food. So again, the idea is that you have this historical process which is cashed out often in evolutionary terms for that determines how content is fixed in the system. So what about this idea of exploiting that you mentioned? Well, the idea of a system exploiting a causal informational relation refers to the way that a system uses these kind of relations, causal informational relations, to its advantage. So, for example, a primitive organism might have a sensory system that responds to certain types of light because this carries information about the time of day, which in turn is useful to, say, regulate its sleep-wake cycle. And so here the organism is exploiting the causal informational relation between light and time of day. Again, to summarize, the teleosemantics and theories in the vicinity of teleosemantics account for representational content by appealing to the functions that mental states have for the system. Well, these functions are determined by what has been historically advantageous for the system. So for an organism, that's kind of what has been evolutionary advantageous in terms of maximizing fitness of the organism's ancestors. And a mental state represents whatever it is its function to carry information about, and this involves the organism exploiting certain causal informational relations. Now, when it comes to artificial systems, that account needs to be a little bit refined or adapted to cases that don't involve an evolutionary history. But here you can just plug in the learning history of the system as a substitute for this evolutionary history. So in the case of large language models, these models don't evolve in the way organisms evolve, but they kind of learn or develop from a learning process, initially from pre-training with network prediction and then from RLHF fine-tuning. And this plays a similar role as evolution in organisms from a teleosemantics perspective. So it fixes certain functions that are brought about by the learning objective. So next word prediction, or in the case of RLHF, kind of reward maximization. And so this is where we can say that the system is exploiting certain causal informational relations because it's using these relations to maximize that learning objective that is determined by the learning process. So I don't really think there is a problem here in terms of like a chicken and egg problem or something like that, right? Because you can just appeal to the nature of the learning objective. And again, the key point is that the learning objective of our LHF is not just intralinguistic, or it doesn't simply rely on the exploitation of intralinguistic functions, but it relies on the exploitation of world-involving functions. And that can fix the content of the system's representations in a telesemantic perspective. So yeah, I hope that helps.
Yeah, I think that makes sense to me. I guess when I was thinking about your teleosemantic perspective, what I kind of found myself wondering that led to this question was when so we're thinking about this like intentional content we might have when it comes to my representation of there being a fire, for instance. And so the telos is something like guiding fire related behavior, perhaps, which seems fundamentally different from representing the presence of fire. And so I guess it seems like you're kind of grounding that out. Like there's some unmoved mover somewhere here, right? That kind of has its intrinsic content that is then providing the demand for content that my representations have, right? And so I guess what I was initially worried about was okay, if I just assume that like guiding fire related behavior, the kind of telos there is this unmoved mover that has that intrinsic content that sort of defines the content of my representation of fire. Like I'm not sure if that's really the right place to locate it. Does that make a little bit more sense as a concern?
So I'm not sure if I maybe I've misunderstood the point. So if you think of fire-related behavior, this is guided by this, historically guided by this evolutionary objective of maximizing, say, inclusive genetic fitness for the organism, and that provides the telos that secures the exploitation of causal informational relations about fire that enables the system to or they say about like about perhaps this example is a bit confusing because we're shifting from the fire smoke common example to talking about relationships between representation and the world. But again, if you think of like the system representing, maybe light is a better example. So having acquiring representations that represent that associate light with the representation of the time of day or something like that for a specific evolutionary advantage that is governed by this maximization of inclusive genetic fitness. So where in that framework is the first mover problem that you're alluding to?
So I guess what I'm thinking about, I guess maybe you've kind of answered the question in terms of this definition is kind of provided. So there's something that's related to like our evolutionary history that's playing here in terms of the definitions we're looking for content. I think that broadly answers my question on this. I'm gonna have to think about this in a little bit more detail. That was kind of my first slice at thinking about this a little bit, and I'm not a super well formed worry just yet. I guess to kind of close out some of the thoughts here, so we've sort of explained, you kind of gave us a very interesting history of the distributional hypothesis and the ways later Wittgenstein has been employed in the service of different theories about language models and what they can or can't know about the world. And so I think when it comes to broadly these questions about grounding, maybe lifting ourselves up a level, we like grounding is a really interesting question for lots of reasons. And I think that it has a lot of bearing on things that we would like to see in the systems we're developing when it comes to honesty and in our interactions with them. And so I do think there is a question of, in terms of gradations, like grounding feels like something that again can kind of exist on a gradient. Like it's not that something is fully grounded or it has no grounding whatsoever. And there's this other paper called Dumb Meaning Machine Learning Artificial Semantics that I think spoke to similar ideas and kind of explored this dumb meaning that LLMs and I guess even multimodal models, although I know you come to a negative conclusion about multimodal models, but this kind of argues that there's something more than syntax going on, and I guess less than meaning proper. When it comes to the idea of meaning proper for humans, there do seem to be a lot of extra linguistic aspects to the ways that you and I engage with the world, the way we experience things, the way things have meaning to us. And so that does feel like something that one might naturally intuit as a bit beyond the scope of what an LLM can like learn about the world and ways in which it can ground its representations. And I think a lot of that is tied into our phenomenological experience, even extending beyond sensory motor concerns. But while that's interesting, I guess there is that question of how much does it matter pragmatically to get systems to do the kinds of things we want them to do? So I guess I'd love to hear you describe maybe a little bit, kind of coming to a close on this grounding problem when it comes to these questions of gradation and developing systems that do the kinds of things we might be interested in as a community right now. What level of grounding, what do you think is important there? And how do you think about some of these questions of like extra linguistic aspects of meaning when it comes to the human experience?
Yeah, that's a great question. And I certainly don't mean to suggest that, and we don't mean to suggest in the paper either, that um, large language models trained on text only have representations that are grounded in the same way and to the same extent than representations are in humans. We just minimally want to claim that the grounding problem can be overcome just in the sense that there can be some degree of referential grounding in language models trained on text only. And somewhat counterintuitively, that means that neither multimodality nor embodiment are necessary conditions to achieve some form of referential grounding. Now, that doesn't mean that you couldn't have systems that would greatly benefit from multimodal representations and embodiments to achieve a greater degree of referential grounding. That certainly seems to be a plausible idea. It does mean that there is this surprising double dissociation between referential grounding and the capacity for multimodal representations or embodiments. So you have embodied systems like this system from Google called SayCan. That's a language model plugged on a robot that can navigate the world and answer natural language instructions. And you have multimodal systems like DALI 2. And neither of these systems, in our view, achieve referential grounding because they don't really have, at least if you take the claim we make about RLHF, they don't really have like the language model component of SayCan and the vision language models like DALI 2, they don't really have anything like any learning process like RLHF fine-tuning that secures the right kind of normative world involving function to acquire referential grounding. So you can have referential grounding from text-only models without multimodality, without embodiments. And vice versa, you can have multimodal or embodied model without referential grounding. But so there is a double dissociation. But I do think that it is plausible that, well, certainly if you look at the human case, of course, we are embodied systems. We are systems that rely on rich multimodal sources of information to understand the world, and our concepts embody rich multimodal information. My concept of a dog, again, is embodying information about what dogs look like, and what dogs sound like when they bark, and what dogs feel like when I touch them, and so on. And that is presumably missing entirely from language models trained on text only. They might learn from descriptions of what a dog looks like, but that will fall short of the right kind of multimodal information that is associated with concepts in rich concepts in the human case. So yeah, I basically I agree that while you can secure some degree of referential grounding from text only training with the right kind of learning objective that secures world involving functions, you presumably have a lot to gain from endowing the systems with multimodality and then embodying them in the real world, even though in order for the systems that are multimodal and embodied to also achieve referential grounding and achieve it to a greater extent, you need them to induce the right kind of world involving function. And that means that you need them to, for example, in the embodiment case, you need a system to adjust its representation of the meaning of words based on these embodied interactions, which is not the case in SEICAN, for example, the system I mentioned, where they just used an off-the-shelf pre-trained language model and then feed the outputs of, feed it as input the natural language instructions like fetch me a can of beer, and then the language models is processing that input, outputting some low-level instruction for the robot, and then the robot is executing these low-level instructions to navigate to the kitchen and grab the can of beer and bring it to the user. In that case, there is no updating of the lexical representations of the language model on the basis of embodiment. There is no change. There's no learning process that occurs. The language model is pre-trained and it is frozen, as people say in computer science. It is no longer being updated. So embodiment doesn't contribute anything to learning, to the historical process that fixes representational content. So what you would need for a more strongly referentially grounded system is a system whose representations are actually further stabilized by a historical learning process involving embodied interactions with the world.
That makes sense to me. And I guess one aspect of that grounding as well, I guess I'm thinking a little bit about like Winograd's kind of classical critique of AI here, and that it's not just like a one-way sort of stabilizing thing that's happening when we like construct meaning and when cognition is occurring, but rather there's this dynamic interaction with the world we have where our brain, our mind helps determine how the world is perceived rather than like grasping this thing that just kind of exists out there for us to represent in a single direction. So that seems also, I guess, kind of relevant to some of these questions. But for the sake of, I guess, closing out here, I realize I've taken up a lot of your time already, but for maybe just a last closing question, I'd love to hear a little bit about, I mean, there are many topics that we didn't really quite get to discuss, but I'm curious just what particular wrinkles or topics that you're thinking about next.
Yeah. So there are I have a number of ongoing projects that continue in the same vein to probe relationships or comparisons between human cognition and deep learning models in different domains, such as language understanding, reasoning, planning, perception, and so on. So one thing I'm very interested in right now is this high-level question of how we can investigate this comparison in a way that is both meaningful and fair to both sides of the comparison. So fair to human cognition and fair to deep learning models. And when I mean fair here, I means that it's actually highly non-trivial to set up experiments or have methodological tools to assess how, for example, whether language models have some kind of cognitive capacity that we ascribe to humans in a way that doesn't stack the deck either in favor of the human or in favor of the language model. In other words, how do we get an apples to apples comparison here? From a methodological standpoint, it's very difficult because whenever you have a certain evaluation tool like a benchmark, there is always a concern that good performance in the benchmark is not going to measure the relevant underlying competence. So there's this potential gap between performance and competence that is relevant here. So I've been thinking about this a lot and talking with various cognitive scientists and computer scientists about how they think about this. And this is related to this bigger project where I've started thinking about, and I have some joint work with Charles Radcliffe about that. Again, thinking about the extreme polarization of current discourse and language models, where a lot of people have this kind of all or nothing approach, where either these models must have human-like intelligence, or they must not be intelligent at all. And we think that this is problematic because, first of all, only appealing to these very sweeping notions like intelligence or understanding, or whether something has a mind or not, doesn't really enable you to make some more fine-grained distinctions between different specific cognitive capacities. But also, this all or nothing thinking is inadequate because there is this vast multidimensional spectrum on which you could locate current systems some way in between the lack of a cognitive capacity altogether and the possession of that capacity at human level. And this is something that is familiar, again, to people working in comparative psychology, for example, in animal cognition, where these people are used to try to resist both anthropomorphism, but also something like a chauvinistic form of anthropocentrism, where you look at whatever is the human manifestation of a given cognitive trait as the gold standard, and whatever system doesn't meet that standard, you say must be lacking that trait altogether. For example, episodic memory or metacognition would be examples that are discussed in the animal case. So we kind of take inspiration from these methodological debates in comparative psychology and developmental psychology to say, look, we need to reject this all or nothing thinking, and we need to adopt a more divide and conquer approach. We look at different individual cognitive traits or capacities on a case-by-case basis in these systems. And we look carefully at empirical evidence with a more open-minded empiricist attitude, and we try to assess the degree to which these systems might be said to possess something analogous to these capacities, even if it's not to the same degree as humans or with the same degree of sophistication. So that's one thing I'm very interested in, and that kind of has ramification for the different capacities you can look at. And then I'm also very interested in the notion of compositionality and reviving old debates about connectionist systems and whether connectionist systems, so artificial neural networks, might be said to possess compositionally structured representations, and what that says in return about how we might think about the human capacity for having compositionally structured representations and processing representations compositionally. So this is a whole large literature and whole discussion. We probably don't have time to get into the details, but that's one thing I'm thinking about, and I think it's an exciting avenue of research. I'm also thinking about the kind of semantic competence of language models, generally speaking, and on the more syntactic side of things, I'm thinking about what the recent development of language models, recent progress might tell us about questions in theoretical linguistics, including kind of Chomskyan arguments about language acquisition, the so-called poverty of the stimulus argument, that says that children might have strong innate learning biases with respect to grammar in order to learn certain constructions. So could we learn in principle from language models trained on a realistic amount of data, and whether these language models can learn syntactic constructions could we use that to constrain the debates on language acquisition in humans? That's another thing I'm thinking about. I have a number of projects related to AI and art as well. There are many interesting questions there when it comes to recent developments of image generation algorithms and other algorithms that are now used by artists. I have a side project with an art historian colleague of mine, looking at the extent to which image generation algorithms understand the style of famous artists beyond the kind of face value reaction when you ask DALL-E 2 or another algorithm to generate a painting in the style of Vincent van Gogh, for example. Someone who's not a trained art historian might think, oh, that's a really perfectly adequate output trying to mimic the style of an artist like Van Gogh. But a trained art historian actually might discern ways in which the model is just latching onto certain features of a style and not others, or things like that. And there are related ways in which we could quantitatively evaluate that kind of thing. There are many other projects, but the guiding thread is for me, and what excites me moving forward is how can we have, again, building inspiration, taking inspiration from work in comparative and developmental psychology, a more subtle ways to set up the comparison between humans and language models or other deep learning models, to get away from sweeping extreme claims that buy into this all or nothing attitude. And methodologically, I'm very excited in particular by this kind of emerging field of research called mechanistic interpretability that involves going beyond behavioral behavioral claim or behavioral evaluation of the models using benchmarks, for example, but actually tries to pry open these models and reverse engineer the circuits that emerge from training within these models to make more causal claims about how these models are representing things and manipulating representations by implementing algorithms that you can empirically discover by painstakingly reverse engineering what's happening inside these models, but you cannot a priori know the model is acquiring just by looking at the architecture of the model or its learning objective. So you really need to do this work of looking at the dynamics of training, looking at what's happening during training, what the model is learning, how it's modifying its internal representations, and then what's happening in the trained model once you're doing inference on the model. And you can learn a lot from that, I think, about how these models actually work and the ways in which they are not stochastic parrots, but actually implement certain algorithms and in some ways end up being much closer, if you look at the right level of analysis, to old school symbolic models, in the sense that a lot of what they're doing, if you interpret it properly with this mechanistic interpretability approach, ends up being close to being cashed out in terms of symbolic manipulations. So sometimes people try to frame discussions about connectionist models as this like absolute dichotomy between symbolic models and sub-symbolic connectionist models. But what's exciting about these models, I think, is that they end up acquiring through training some mechanisms that can do things like variable binding variables to values, things that classically were thought to be only possible in classical symbolic models. But I'll stop here. That's already long.
There are a lot of fascinating insights coming from the mechanistic interpretability direction. So, well, I have been a very excited follower of your work and will continue to be following it with a lot of interest. So, Professor Millière, I do want to thank you for being so generous with your time today and for speaking with me.
Thank you for having me. I really enjoyed this conversation.
And that is a wrap, my friends. As I mentioned at the start of the episode, you can subscribe to The Gradient on Substack to receive not just this podcast, but also our articles and newsletters directly to your email. You can also visit us at thegradient.pub, where you'll find all of that, as well as more information about the gradient and how you could even contribute if you're interested. And finally, if you enjoyed this episode, we would really appreciate your feedback. If you'd like to leave a comment or review, we'd love to know how we can make this series more interesting and informative to you. And with all that, I'll leave you until the next episode.